So hello everyone, I am returning here. Akash here. We are so my OS project is currently going fine-ish, and it's slow progress for now because the easy part is over. So I am currently reading more about the next parts, as it's mostly trial and error too, and documentations. So in the meantime, I try to make my own shell, which is Unix style. So let me walk you guys through that. So it's here, yeah. So let me show you guys first its working model. As you can I see that it's here. We can work uh, like back, and I implemented PWD in the loop. I will show you guys code so that each after each successful command I get the pathway is shown. It's absolute path. The next step is I will implement the relative path in some time later. Uh, so you guys can see ls is working. I can enter here and like cat a file. Yeah, the project is in C++, because I mostly work in those languages, C and C++, hence it's here. Yeah. Yeah, it can execute all the external binaries, and it has some built-in commands too, like pwd, cd, and type. Like I can type what is cd, and I will get cd is a cell built-in. Yeah. Now let me show you guys the total project. Yeah. So here it's main file. So since you guys must know that cell is like a REPL. So for REPL you basically give it an infinite loop, and so in the next prompt here it's cout, and it in normal shells you get this dollar sign, so it's printing this. We get the next line input from getLine command, and here the command variable string. If it's blank, we just continue for the next and exit the loop. If it's not blank, there is some string or something, then we parse the command, and we print the next line, and we show the current working directory. Okay. This here is logic for exiting the shell. Now let me show you guys the build structure of my. So in this command directory, I have all the commands written, including its include file, and yeah, and here wait a second. And this is the command parser command, and this my split, the tokenization. Yeah, let me walk you guys through first the command parser. So basically we get the memory address of the text. Yeah, you can think of it as a memory address. This dollar sign indicates its memory address, and we implement this split. So what on the basis of, and split command I will show you guys in a minute, and then we have this function implemented, which basically gives us a map, yeah, an ordered map of the whole command built-in command sets we currently have, and then we run the loop here, and if we found the built-in command, we just like you can see that second dot callback to run that function, and if it's not there, then it's likely external command, and its error is handled there, and we return it. If it isn't found anywhere, yeah, I mean the external command returns are true when it's executed, boolean true. So when it's boolean true, then it returns. If it returns false, then we don't enter this if loop, and hence don't return. And here we give that command was not found. Yeah, command not found that you commonly see in shells. Now let me show you guys my split. It's fairly simple. Here we are taking the text we want to like tokenize, and the vector we are storing the splitted, and the character on which basis we are going to divide that. And here we are like finding the position of each. It's got simple code. I don't think it's very obvious. I don't think there is much to explain about this. Yeah, it's standard. I would say quite easy. You guys can see how we are like looping through it and finding each the position of the next of that character and just splitting them on the basis of that. Yeah. Now let me show you guys the interfaces. Like we have this built-in. It currently have the echo command, the type command, the exit command, the pw command, and the cd command. Now it's likely here. This is type command. So in the type command, if like we have the yeah, let me show you guys first how this is implemented, right? So when you go to this and execute external, like command dot find, so the command structure is something here stored, command register. So here this is the unordered set, and when like you get the echo command, then it's execute this cmd.echo function. When you get the type command, you execute this cmd.type function. So like just it's in the command parser, if it finds the name equal to that command register, this name key, and then we execute this function. Yeah. Now like this is the type command, and in the type command, if we don't find anything, then we just print. We don't have actually any argument, then we just type that it's missing. The first argument is always like must be the type word, and second argument should be there for this to work. Then we get all the commands we need from the get commands, which we have this in here, get commands function, which returns this unordered map, and we get the name of the command from the argument. 0 must be the name type itself, and the argument 1 must be the name of the command. We find the command, and if it's there in the command, we say it's a shell built-in, and we have something called execute status. It basically searches if the command is in the path available to the shell and is executable or not. If it's executable, then we print that this is a command found in this path. Let me demonstrate how it's done. Okay. Like I say type ls, I get that ls is a USR bin where the ls is located. Then it's in the user bin file. Okay, just like that. So here it first determines if the command is available to the shell or not, and if it's not available, then it's basically that command is not found, and if it's available, then we just print its name and where it's located. Next, let me show you guys how the execute status works. So here it's basically we get all the paths we have, then we split. Yeah, we get all the paths, and this is basically saying either if path is not empty or empty. and then we just split it and it's stored in this vector v. Then we iterate over this, and we get the absolute path by appending the name and this slash. Is it forward slash or backward? Backslash? Yeah, backslash and the name. And if it's executable is a function which I have written here, and if it's executable, then it's executed. It's written actually. The path is written. Is executable is very simple. The UNIX systems provide this ABI command, the access, which helps you determine whether the path is available or not, and is it executable. The path takes the input in the character pointer, so I gave it here by like typecasting it back to C style string. Yeah. After that, it's very simple. Echo, just loop over the words and print them on the shell. Let me show you the execute command program. Yeah. So this is the execute command. It's I think you guys must have been familiar with the by now the what this is. This is basically arguments we are getting, and if it's empty, we return false, obviously, because there is nothing to do with it. If it's and then we build. So basically, let me show this exe cpv. Basically, it takes an, I would say, you can say a C style array. Okay, C style array as the data, and the first being the command. Okay, it's basically command and argument. The argument's 0th index must also be command. I actually made the mistake of like excluding here, and it caused quite a bug. But yeah, you have to include the whole array here, and you also have to give the first index here. I don't know why they did that. If we are like giving them here the argument, the total argument, then they should be able to infer the which type of command it is. Most likely forcing us to explicitly declare which type of command we are like giving them. Maybe there is some weird command which like requires you to put the command in the middle or something. I don't know. Yeah, so it basically runs like this. We first build the character array. You can see I mean string. Basically this is vector. You can think of that as a 2D array. It's basically array of strings pointed to character. Yeah, I don't know. It's slightly weird. Yeah. But yeah, you build it, you push back. I const cast it because this is string, and we are just casting it here and pushing it back to argv. Yeah, and in the it's necessary for us to like provide this last null in the string in the array to like make the API know when our arrays end, when our arguments end. So you push the last null. Then we fork our process, and like for the child process PID is always 0. Then in child process this code will be executed. So this is executed, and basically when this exe cpv vp works, then it returns nothing. But if it returns something, then this line will run, and this will show that command was not found because we got error, like we got thrown out. And well, we exit after printing the error message. If PID is less than 0, then return false, basically, and forking didn't work, and because PID you don't get negative PIDs. And here we are just declaring whether the program worked with PID. If a status is like less than 0, then the program didn't work, and we just return. Yeah, it's just executing. These are just the error handlings, this part. most of the work is done in this if loop. And then yeah, I would say this exit was very like I would say interesting. Basically what we are doing here is I have declared this in here. Yeah, this is a structure exit cell. It doesn't do anything, but I needed something like a common interface for exit command too. I could have like just had it in main file. If the command, if the argument is like exit or something, then we just exit the REPL, but I wanted something like common interface, so I built this. So you get the struct exit struct, and we built it to like, let me show you. If for command exit, if we type this, then we just throw this empty struct, and in the main file, if we like find catch it, it's like searching for this exit shell. If it's catch, then we exit the try block, and the for a loop is exited, and like program ends. Yeah, I found I think this is quite clever. Well, I am very new to C++, so maybe not so much, but I like this. PW is very simple. There is this get cwd command, in which you give it the buffer where you will store the current path, and it just returns the current path in that buffer character. Yeah, and we just print it. CD is also like that. Let me show you. System calls actually makes it pretty easy to build your own cell, I would say. You get like here it's slightly more like maybe code looks complicated, but it's nothing much. If like size is less, character size is greater than 1, only then we like I am declaring here a string. It's basically the path we will get. You type like this now, and you like path like this. So here this is the argument. Yeah, so we are basically searching for the if we have the argument. If like we have the argument, then the string is assigned that argument, and we have this character path declared here. And if it's this tidal sign, then we like if we type this tidal, we return into our home user, hyper user, and we were here but we got here. But yeah, then we return here our home. That get env basically gives you the path to where the variable what the variable is. Like when you export it in cells, you get using those variable get env. It's c style stdlib.h and unit std. I think it was in cd, no? Yeah, and we just have the path declared path. I mean path is equal to, if this, then path is equal to this, else path is dot data. The s is basically the second argument, and this is a change directory command. It's a UNIX interface we get, and we just it returns 0 if everything went right. It returns something like error codes which when something doesn't go right. So if it's not 0, we just print an error statement, and such file and directory doesn't exist. Yeah, this is our CLI command structure. It contains a name, a description, and that callback function. And this is the get. It's a common practice. I also made in some other of my codes this type of structure. I like this type of ordering for the built-in REPL. In the REPLs, this helps very much. Like when if I ever needed to like have the help command, then I can just iterate over this and print all this, like print echo, and it prints its description, print type and prints its description, like that. So yeah, that helps. Hopefully you enjoyed it, and I will post the GitHub repo link in the description so you guys can explore this in much more detail, because I can only cover just that much. And I am actively working on this currently right now, so it will likely it doesn't actually have the quoting, pipelining, and all those nice to have features you see in the modern day cells like bash, and but I would say it's yeah, it's currently in the baby phase, but it's complete in a way that you can work with almost whatever you want. Like everything is almost working. You get the shell and such. Yeah. Thank you.